Welcome. Biomechanics is whenever we are doing something or interacting with some product, maybe simple holding a pen or opening a tap, we are exerting some force. So, what amount of force is required to operate some product, or how much force can exert by a person or the user, that is very important to know when you are designing some product. In this backdrop, the information we require about the strength of the person or force how much exert they can the user, that information we can get from biomechanics. So, in this discussion mainly we will discuss how it is relevant to with product design and how we can get benefit using biomechanics in our product. So, let us first run a video. So, here you can see one product that is a can opener, and we have one can, and if you see the product, the person is trying to open the can, and once he has done this, once he has clipped this can, he locked it, and then he is trying to rotate this thing throughout the edge of the can. That is the video we have seen here. So, this is a very common product what we are usually seeing in our day to day activities, and it is very useful to make our food, and it is such a product where this product can be used by a person whose age is maybe 12-13 years or a adult person. Also it can be used by a elderly person. So, as you have seen this product, when the person was using this product, we needed certain type of force, or rather to operate this thing. So, first he or she has hold this product and hold this part of this product, and then he has twisted it, and he has used certain torque because it's a circular object, and then it has he has revolved this around the edge of this can, and finally this can got opened. So, if you think the range of the population, so as it may be possible, and that a kid from a kid to a elderly, so obviously the torque you need to generate here to open this can is obviously not same for the kid and the elderly person. So, we have to understand the information that how much one elderly person can exert or how much a kid can exert. If that will be sufficient to open this can, then only this product will be useful for a range of population. So, in this case, first thing, if we think of this thing, physical interaction, first this person is holding this thing. So, obviously this portion, this dimension of this thing should be compatible with the person who is holding, and also this handle of the part should be very compatible with the person who is holding this thing, and also which is rotating this thing, and then you need certain force to revolve around this. So, in this type of case, these are the biomechanical aspects we need to think of, that is the information related to the force, how much they can exert, those information is very important, and how much strength you need, these are information you require from the point of view of biomechanics to design certain product. Now, if you see this can opener, that is the earlier one, that is a classic can opener which is made of steel. If you can see this thing, almost same thing, in here it is a wing nut is there, and you have to just rotate this thing, and then you this can will got open. But if you see, compared to this product, it is a steel made and the dimension it is very flat, so it is not actually compatible with the whole holding of this thing. If it is something circular, then it is very easy for us to hold it and properly grip it and then use that product, which is very easy for this product. But in this case it is not very easy because this is a flat one. Also this wing nut thing, to hold this thing and after that holding to exert certain force, it is pretty difficult. So when you are designing, and due to this form and material used and the shape of this thing will also influence the force and the exertion of the person. So people will not be very comfortable and easy for use. It's not very easy for use and efficient to use. If you think of the product redesign and innovation, so when we are redesigning that product, we can think of the form of this thing. So from there we can think of this form, the material, and how much easily it can be hold. And once you can hold it very easily, then you can use it very efficiently. So if you see this modification from here, it is a more useful, more user centered. Then if you see the latest product, it is battery operated, and here in this case only a switch is there, which you can see here. Only once we press it, it will just cut the scan and it is over. Then you can press again this switch and it is it will be switched off. So in this case, as we have discussed about the load, means performance load, and we have discussed earlier that performance load can be two types. One is physical performance load and another is cognitive. So in this case, obviously the physical load is getting very much minimized because you don't need any force to exert any torques, just only to click of a switch, it's reduced drastically. And also it's very easy to use and it's nice to see. So those things. Also the another very important point when we are designing any product is, once you are taking of this thing, what is remaining. In few cases, if you see this product, once it's coming out, this edge is very sharp. If your product is cutting like this and you are remaining with a very sharp edge, so it can be very unsafe from the point of view of further use of this content. So once you are designing, you have to understand the biomechanics and the person form, what is the material, how it will manufactured, and how much force they can exert. Simultaneously you should think, once you have used this thing, whatever remaining portion is there, how it will be safe for the person, or how much user centered it is. Because if it is a very unsafe thing, it can cause harm for this person, accident or injury may happen. So when we are designing something, we should think before the tool, how it will be designed, how it will be used here, and after using that product, how safe it is. So it shouldn't keep any unsafe edge or this thing. So this is briefly the why we need biomechanics and how it can be applied in a product. So we have discussed one single product. Now we will move to the overview of the biomechanics. It is a very common pictures. We have taken it from 3 different workstation. Whenever we are doing something, we need to adopt some posture. As it is very obvious, you have seen that when you are working for a longer time, so we are feeling a bit pain and discomfort in our body. So we change our posture and we are going for 1 minute break, 2 minutes break, again we are coming like this. So but it is very important that how the posture will be. So posture can be like this, posture can be like this, and like this also. Posture will very much dependent on the work or the product you are using, how you are using. So in this case, if you see, this product is demanding this thing, and also this person is adapting to make it more efficiently. In this case also, this person is trying to view this thing, so he is adapting such posture, and also the height of the table chair is not compatible enough so that it can be of same height. So then there won't be this bending will happen. In this case, it's some ladies are working. In this case, they adapt some squatting posture, which is very difficult to sit for a longer time. and they are adapting some posture. So in this case, this whole back, it is very getting strengthened, and again they are doing something, extending their hand and doing some activity. So depending on the posture they are adapting, this biomechanical demand will be very different depending on the different workstation, different activity you are doing, like this. So next, when you are in motion, in these cases what we have discussed, in all these cases mostly the person is in static condition. It is not fully static, but mostly there is no such motion from one point to another. Now we will move to the next slide, where the person is moving from one point to another, or like this, or he is lifting something, some trolley or something. So in this case, what happen, in this case posture is also very important, because in such condition, if you take this thing, this lady is adapting some posture to maintain his balance in this hilly condition, and also she is using this shovel to take this stones out. So he is using some force here, and he is also maintaining his balance. So things is far more complex than the person is sitting or standing in a plain land. Another thing, when this lady, if you see this thing, this person is unloading some stone from the ground, and she is putting this thing in this. In this case, the person has a very high load here, and she is extending this thing top of her head, and she is putting this thing here. In this case, what is happening, once is this balance is very bad, because this whole load is on the top of her head, and also she is extending to reach this thing. So once this reach will be far more extended than the ability of the person, the posture will be very risky from the point of view of user. Another thing we can see here, we have seen so many cases, the person is holding some load and transferring from one place to another. This is one such condition. This lady is walking from one place to another place, carrying this thing. So the way the person is carrying this thing, the mode, whether she is putting this on top of her head, or in one side, or both side, or in the back of the head, or here maybe like a bucket holding in front here. So these things is these issues are very important, how the load has been carried by the lady and how it is influencing the posture. Depending on the load and mode of the load carrying, the posture will be more complex or can be more risky and dangerous from the person point of view. Another thing is very important, that is amount of load. Another thing is what is the frequency of the person, or how many times she or he is doing that thing, or what is the time duration. These are the issues which can be very important criteria to understand the risk of the posture the person is adopting. This is another very common thing we are seeing, the lifting of load. So it is important what is the posture they are adopting when they are lifting a load. If you see this thing, so we can take another example. When we are seeing the weighing machine, so if you have certain load in this thing and in here and here, so and you can put some weight here. If you can, your fulcrum is here, and if you are putting certain load here, if this is equal to this thing, what will happen? This thing will be here only. There will be no movement in this side or in this side. But if you put this load in this side, what will happen? This thing will come here, and this thing will be like this. So in this case, what will happen? If you think of this load, in this case, this load is getting in one side. So in this case, this portion is getting bending down, and this portion has to increase the strength. This portion has to take the load so that it can be lifted out from here to here. So this is a simple mechanics. So if we use this thing in this case, the load is getting in one side and this portion of the muscle is getting more stressed to lift this load from ground to top of her head. In this case, what we see, this maintaining of the posture and the awkward posture or the posture the person is adapting is very crucial. So if it will be nearer to the body or the way the person is handling, if it will be bended from the knee, then this will be more easier to lift the load. So it is very important in case of any designing of product, how far distance it will be. This is how far distance it will be from the person, so that it will be, if the load is nearer to the axis of the body, the efficiency will be more. If certain thing, maybe bucket or something you are holding like this, if this is more like this shape, it will be very difficult to hold and carry. In that case, if it will be nearer to the body and if you cut this part, then it will be more easier. So when you are designing some product or object where it will be carried from one part to another, something like this, then we should take care of the shape of the object, how it will be and how efficiently it can be carried, taking care the safety of the user. So this is another example when we are sitting in any place. Usually when we are standing, our spinal cord is something like this A shape, and we are preferring something chair or something where usually we have a support like this thing. But if you see, when we are sitting for a longer time, usually we are adapting so something like this posture, because we can't sit erect like this for a longer time. So if our chair is something like this, usually we are getting ourselves bending down and we are using this thing. So in this case, if you see, our spinal cord become this C shape. This is very risky and dangerous posture when the person is adapting. In this case, if our work table is here or our monitor is something here, then we are usually adapting this type of thing. But it is very important to keep our spinal cord like this shape. So if we want to correct our posture from this to this, what we can do, we can make it from sitting to standing condition. So if we stand, again it will be C shape, but it is not possible to stand for a long time. So what else we can do, it can be something in between. Usually we are seeing chair something like this. So it is not, if you see this chair, it is kneeling chair. So in this case, it's not a 90-degree thing, it is, this angle is like this, it is more. So if you see this angle, this is much more than 90. It is usually in our conventional chair we will have something like this. In this kneeling chair we have angle like this. So in this case, it's not actually standing, but it's you have increased this angle. So if we increase this angle, this posture of the spinal cord will again be S shape. So how it matters to our product design? So when we are designing something, workstation, work table, modular furniture, when we need to adapt certain sitting posture for a longer time, we should think of something like this, where we can adapt sitting, standing, not only sitting or not only standing. We should think of both sitting, standing condition, so the person will be able to sit, stand both. And also obviously the adjustability. So if it is some workstation that which will be used by many people, so then we should think of the adjustment of the person, so that they can change the height and workstation height, everything depending on the need of the person. So next we have discussed right now that what are the issues we should think when we are designing something. What is the lifting, what will be lifted, mode of carrying, we have discussed this, how it will be mode of carrying, handling of the object, how it will be handled, and the frequency and another thing is the time, means how many times. So these are the few important factors when we are designing something like this object, what can be handled, means it can be some very heavy object, cartoon, or it can be something very barrel, like this, what will be transported from one place to another. These things should be noted. Another thing, how the person will bend, so there can be some mechanism, so this level will be minimized. So if it will be raised from ground to here, then it will be very difficult. But if some table or something is there and the load is here and the person is here, so obviously the load will be far more decreased than from taking it from the ground. So obviously we can change the posture in this way to put something. So when you are designing some furniture or this object, we have to take care of these things. It will depend on the how many times the person is doing. So it is very important to understand the biomechanical issues when you are designing something, workstation, this type of object, all this. So next, very briefly, so when we are designing this type of workstation or something, what are the principles, means what are the requirements. So first is obviously we are visual, so visual requirements is the first priority. So when we are doing something, maybe aligning something, or we are putting some fixture on some product, then is a visual requirement is the first requirement. We need to see what we are doing. So first is we should take care how the visual requirement will be fulfilled from the design of the furniture or workstation. Next is the postural requirement. Posture, what are the postures the person can adopt. For example, if we see the customer care section or billing section, with whom we are interacting, paying our bill in electricity, telephones, like this, we are seeing the person is sitting and the person is taking the bill from us, then he or she is scanning this barcode and everything, he is checking what is the amount, then they are taking that amount from us, and then if there is balance they are giving you. If they need something to scan or something, take some changes, they again rotate to some other corner table, then they will take that, grab that, then they will take a printout. Maybe for printer they have to rotate from, if we take this thing, maybe they have to take here printer is there, the main desk is there, where their window is there, where here they are interacting with the you, and here it is the main computer is there, here is the. So what are the postural requirement depending on the work they are performing. So first is the visual requirement, all these places should be very much visible to that person. What are the postural requirements? So if you see this type of thing, the person need to rotate his spinal cord and he or she has to adopt this various posture in this type of cases. So we should think, when we are designing modular furniture for this type of case, we should think how this postural requirement, visual requirement and temporal requirement. So we have discussed this, a time related to time, how long the person will sit. If you are designing some furniture where the person will sit maybe hardly for 5 minutes, 10 minutes, then it is not that risky. But if the person may be office or somewhere, the person will adopt that posture maybe 7 to 8 hours or more, then we should consider all these factors in first priority to design the whole furniture or the work desk. So what is the principle? Now we can see from this picture, if we see this thing, this is the person is sitting, this is a top view, and this person, if we see this, usually our hand from our elbow we can rotate with our right hand, this part is very easily we can access. For same thing for left hand, from with elbow we can use that portion. So this is the most easy way how we can use. Usually we are not extending our hand to reach something, whatever we want to keep it very accessible, we are putting nearer to us. So when you are thinking something to put very nearer to your body in the when you are designing some furniture where you know this person will use these products very frequently, each and every time maybe, So then you put whatever is in this primary zone, where the person can very easily, that is with folding from their elbow, very easily they can access this primary area. So and also with both hands they can act. If you see this part with both hands they can access. So whatever is important you put, use this part, and whatever is maybe very precisely you need to see and use both hand area, maybe you have to fix using both hand, then you use this part. And if you have to take something and put it something, then you can use this area to put, then you move it to this part. So this is the primary area. Next, if we extend a bit, this is the secondary area. If your hand will be extended, if you see, this is the next level priority, second priority thing you can put like this. So this is the secondary area. Same thing is from left hand. Next is the tertiary area. What is dependent on the reach? We have discussed about reach dimension in anthropometry. So if you extend your full hand, in this case, this is the maximum reach you can have. For left hand this is the part, and for right hand this is the part. So what is less needed if you are designing, if you see the from where we are getting the boarding pass. So we have seen that workstation, there is some decorative item, maybe flower vase or something, you can put those thing here, because this person is not using this thing randomly. So put all these thing in tertiary area, what is the maximum reach of the person or more than that, but whatever they are accessing, those things are in priority and use this area. So these are the basic principle how you can design a furniture depending on the person's activity performance, what are the activity they will do, and obviously we need to consider the visual requirement, posture requirement and temporal requirement. Now just going to a very brief case study. So here this is a very common picture we are seeing in a hairdressing scissor. So this is one example where we will discuss very briefly how you can intervene your product. We have seen one example in case of can opener. We will see another product how actually you can take the ergonomics principles, how you can implement those ergonomics principles in your design. So this is one example of a hairdressing scissor, or it's called shear, and what this is, one person is professional is cutting the hair, if you see. So if you see this thing, they are adapting certain posture to hold the shear and use it efficiently. Also depending on the part of hairs they are cutting, so they are changing the posture and the way they are holding that hand, holding the shear. So in this case, so in this case we have project, we have first we have understood that how the person is existing condition with existing scissor, which is this one, how the person is adapting. In this case they are putting their thumb here and other fingers they are resting here. So now you with using the existing shear, they are having some pain point here. These are the place they are having this red area, they are having pressure and pain point, they are having pain and discomfort in this area and blister they are developing. So because when they are adapting this posture, as we have discussed, the reference is like this. So if you have some posture like this, it is very easy to do. Whenever you will hold something, we are adapting very different posture. If you take this type of scissor, you are adapting something posture like this. If you are using some posture, so obviously when you are feeling this thing, it's very comfortable. Once you are changing this thing and you are exerting some force here, you will feel pain and discomfort in this part very much, and when you are doing this, it's number of times in a day, it is very difficult. So how to correct this posture? If we can do this thing, then it is easy. So now we have this thing, so how to correct? If we can do this thing, this is easier. So in this case what you have to do, it will be something like this and it will be nearer to that. So depending on that, we have done some modification in this case. So if you see this thing, one the existing shear is here. So and this is a right eye hole of that thing, that shear we have changed. So if you see, another very important point is where the person is resting their hand. If you see, the person is resting her finger in this part, but there is nothing is there, so obviously it's that edge is it's hurting, and for a longer use they are controlling their hand, so it is pretty difficult to manipulate. So in this case something can be there so that the person can rest their hand. And also another thing, to correct the posture, if here we have done some modification in the left eye of the seizure. So left eye has been changed so that this existing condition, so this posture is something like this. So in this case, as we have changed first thing this thing, so here the person can rest very easily. Also we have corrected this, in this case as the both eye are in the same plane, so it is you have to adapt your fingers with this scissor. Here we are considering the neutral position, we have corrected the position of the, now it is not in a same plane. So as we have changed this thing, so if you see this thing, so from there we have tried to adapt this shear with the natural portion or the neutral position of the hand, tried to correct however it is possible. Obviously once you are doing this thing, first thing, due to this part the person can rest their hand, it is easier to do comfortable more. And with these changes, when we are modifying this angle, by that thing we are changing also the angle of the person, how they are holding. From there it has come like this. So how they are holding this scissor, how you can correct the posture, how you can implement the biomechanical issues in your product design. Finally this is the rendered product you can see here, and these are the dimension, because this dimension also, if you see the first thing, in each of these case it was rounded. So as it is rounded, so the person was having some problem to hold it. So now also we have changed the eye hole of the scissor. So by this thing, with the final product we have corrected few things. One is the pen point, we have it is more comfortable because they are getting the support, and also we have taken the ergonomics intervention from the point of view of biomechanics, and we have tried to modify or redesign that thing, taking care the biomechanical issues of the person. So this is one example how we can just to show you how we can take the biomechanics, importance of biomechanics, and how we can use these biomechanical issues in our design intervention. Thank you.